The effects of the pressure generated by the single-action pumping system irrigation flow during ureterorhinoscopy on the kidney function post-operatively, a quantitative research. Ureterorhinoscopy is a commonly performed urological procedure that has got major diagnostic and therapeutic values. This involved telescopic fragmentation or removal of stones from the kidneys or the ureters, visualizing the inside of the kidneys and ureters, and also in taking tissue samples if needed. During ureterorhinoscopy procedures, irrigation fluid is used to improve visibility and to ensure a successful procedure. Visibility during these operations depend on many factors such as the presence of floating debris, bleeding, irrigation, and illumination. Michael et al. In their urodynamic pressure evaluation of the renal pelvis and flow capacity study has compared the conventional high-pressure ureteroscope versus the newly developed continuous flow ureterorhinoscopes. They have found that in order to provide a clear field of vision during ureterorhinoscopy, it's a common practice to pressurize the irrigation fluid, hence ensuring good visibility. In many of these procedures, an operator-dependent single-action pumping system is used to provide a controlled irrigation through the endoscope. The pumping system delivers the desired amount of fluid required to improve visibility at various pressures depending on the force applied while pumping. It's important to ensure that the urological interventions used, whether aiming to investigate or to treat patients, are screened for potential harmful side effects. Therefore, this study has identified the risk of acute kidney injury as a potential problem that we would be subjecting patients to in cases of ureterorhinoscopies. Schwab et al. In their experimental study on the morphological and physiological changes in the urinary tract associated with ureteral dilatation and ureterorhinoscopy has demonstrated that high-pressure irrigations of the kidneys in pigs caused irreversible damage to the renal parenchyma. The proposed study aimed to identify any correlation between pressures generated by the single-action pumping system, which is used in ureterorhinoscopy procedures, with any deterioration in renal function. Should a correlation between the increased renal pressure generated by the irrigation fluid system and a reduction in the kidney function prove to be present, then further research needs to be carried out to find out the safe pressure ranges and to what extent can the pressure be increased without causing a reduction in the kidney function. Particularly, this can aid developing a safety mechanism that relieve the pressure should a certain threshold be reached. The published literature on the effects of high pressure on the kidney function, the use of irrigation during ureterorhinoscopy, and the measurement of intrarenal pressure was reviewed. The literature search was carried out by accessing electronic database for urological procedures, published papers on measurement of intrarenal pressure, and the effects of high pressures on the kidneys. The European Association of Urologists guidelines that published in 2015 were also accessed. The following table illustrates the databases accessed with the search results and their relevance. The keywords used for the literature search were ureterorhinoscopy, irrigation fluid, intrarenal pressure, and these were combined with measurement post-operative. The inclusion criteria were English language, studies that used non-invasive methods in measuring intrarenal pressure, and published articles. The exclusion criteria were studies used observational design, study used a qualitative methodology, and studies included pharmacologic modulation of the ureters. Search results. The literature search has not produced a vast amount of results on this particular subject. However, it did come up with some articles that explored methods of measuring intrarenal pressures and the effects of high irrigation fluid pressure on the kidney. 10 published papers and articles were reviewed. The European Association of Urology Guidelines on Ureterorhinoscopy that was published in 2015 were also reviewed. Looking at the available literature on the effects of irrigation fluid pressure on the pressure generated in the kidney, it's obvious that many authors have concluded the presence of a direct correlation between the two pressures. Furthermore, the resulting increase in intrarenal pressure was found to have direct effect on the kidney tissue, resulting in a clear damage, with the possibility of associated complications such as sepsis. However, there appears to be a dearth of evidence about the effect of high pressure generated by the irrigation fluid during ureterorhinoscopy on the kidney function post-operatively. There were 4 key themes for the literature review: methods of measuring intrarenal pressure, the presence of relation between the high pressure in the kidney and the deterioration of the kidney function, the effects of high irrigation fluid pressure on the kidney tissue, and lastly, the direct correlation between the irrigation fluid pressure and rise in the intrarenal pressure. The first theme, methods of measurement of intrarenal pressure. In 2012, an article by Yisai et al. Concluded a new non-invasive method for measuring pressures in the upper urinary tract during ureteroscopic procedures. The main aim of this particular article was to develop a test method for measuring pressures in the upper urinary tract during ureteroscopic procedures. Standard ureteroscopic operating methods were applied. They released the on and off switch in the tail of the ureteroscope. The intraluminal pressure then from the ureter was transmuted along with the irrigant flow and could be measured by a sensitive electric pressure signal transducer. They found a significant correlation between the pressure value and the renal function. However, they could be criticized on the low number of patients participating in the study and the fact that they have included patients with chronically obstructed kidneys. In long-term obstructed kidneys, the kidney function will be chronically affected. This suggests that the technique might not reflect the actual kidney function at the period of time following the operation. Thus, correlation can be inaccurate. Theme number 2, the presence of a relation between the high pressure in the kidney and the deterioration of kidney function. Yisai et al. In 2012, as mentioned before, proved the presence of a correlation between the pressure value and the kidney function. The study identified that high pressures can lead to a reduction in the estimated glomerular filtration rate, thus reduction in the kidney function post-operatively. Another study by Helling-Jung and Pali-JS author in 2012 investigated the intraluminal pressure profiles during flexible ureterorhinoscopy. They have identified the threshold for pilovenous and pilosinus backflow to be in the range between 30 to 40 mm Hg. Data collected demonstrated that intraluminal renal pelvic pressure peaked up to 328 mm Hg during ureterorhinoscopy, which dramatically exceeds the previously mentioned threshold, leading to possible adverse effects such as septic complications affecting the kidney function and then also leading to systemic complications. Fluid electrolyte and renal pelvic pressure changes during ureteroscopy lithotripsy study also concluded the fact that high pressures in the kidney were found to cause renal damage. The last two mentioned studies can be criticized for the low number of participants. Also, the accuracy of the measured pressure value, as the pressure depends on the type of irrigant, the use of the single action pumping system, the length of the scope, and the fluid source height. Also, a question can be raised that if the irrigation fluid pressure was translated to renal pelvic pressure, as the latter depends on several factors such as actual system capacity, external pressure exerted by the external structures, and the actual urine flow and the tension in the pelvic wall. Theme number 3, the effects of high irrigation fluid pressure on the kidney tissue. Schwab et al. In 1993 has conducted an experimental study which compared the changes in pigs' renal parenchyma when they used high irrigation fluid pressure put through the ureter of the harvested kidneys with the changes when they used low irrigation fluid pressure. They have concluded that high irrigation fluid pressure have indeed caused significant damage to the renal parenchyma. Acutely, the high pressures cause diffuse flattening and denudation of the calical urothelium, congestion and submucosal edema. These changes were not observed in the calyces that were subjected to low irrigation fluid pressure. The study could be criticized for the low number of study subjects and for the fact that they used harvested kidneys, mainly because in this way it will be difficult to differentiate between changes that are caused by ischemia and those are caused by high irrigation fluid pressure. However, it could be argued that high irrigation fluid pressure has had considerable effects on the kidney tissue, which was found to be damaged. Theme number 4, the direct correlation between the irrigation fluid pressure and a rise in the intrarenal pressure. In 2012, a study aimed to assess renal pelvic pressure and fluid electrolyte changes during ureteroscopic lithotripsy found a significant correlation between a rise in the renal pelvic pressure and the irrigation fluid pressure. Renal pelvic pressures were measured using urodynamic studies. As the irrigation fluid pressure increased, this has led to a rise in the renal pelvic pressure, thus proving a direct relation between a rise in the intrarenal pressure during ureteroscopy and the use of pressurized irrigation fluid. The study also found that renal pelvic pressures during the surgery was much higher when compared to the baseline. The high intrarenal pressure was found to cause pilostinous and pilovenous or pylolymphatic backflow of the irrigation fluid. If this condition lasted for some time, the pressures in the kidney tubules, especially the convoluted tubules, would increase with the excretion of urine, which in turn oppresses blood vessels near the renal tubules, resulting in anoxia or atrophy of the renal tissue, leading to tissue damage. Looking at this study, it was clear that there was a significant correlation between the irrigation fluid pressure and the rise in the renal pelvic pressure. Added to that, the high pressures in the kidney were found to cause a degree of renal tissue damage. However, one could criticize this study for having a small number of participants, as they only have included 15 patients in their study. Themes versus study. Looking at the previous theme, it was clear that measurement of ureteric pressure using the ureteroscope has proven to be a non-invasive, convenient, practical, and reproducible procedure. The proposed study aims to use a quantitative research method to the cause experimental design to measure these pressures by using a pressure monitor attached to the irrigation fluid source, the single action pumping system, which is used in such procedures to regulate the flow of the irrigation fluid as it pumped into the kidneys. The researcher would then look to see if there is any fall in the kidney function by measuring the estimated glomerular filtration rate post-operatively and where there is a correlation between these and variable pressures applied. Furthermore, the themes proved the presence of a significant correlation between a rise in the renal pelvic pressure and the irrigation fluid pressure, and also the harm effects of high pressures in the kidney, leading to deterioration of the kidney function, damage to the tissues of the kidney, and also the risk of presence of complications. The study has identified the risk of acute kidney injury as a potential problem that we will be subjecting patients to in cases of ureteral rhinoscopies. And our target is to try to identify if the pressurized fluid being used during these procedures will have an effect on the kidneys of patients being subjected to such pressure and measure this damage by looking at the kidney function postoperatively. Research aims, questions, and objectives. My research aimed to identify the gap in the knowledge by finding the correlation between irrigation fluid pressure generated by the single-action pumping system with any deterioration of the kidney function postoperatively in patients who undergo ureteral rhinoscopy operations. The question being asked is that does the irrigation fluid pressure generated by the use of the single-action pumping system during ureteral rhinoscopy operations have an effect on the kidney function postoperatively? The research objectives are: number one, to identify the risk of acute kidney injury as a result of using the pressurized irrigation fluid during these procedures. Number two, and if this risk is present, how can it be prevented? What measures can be taken to avoid or eliminate the risk? And number three is to ensure that the urological interventions used, whether aiming to investigate or treat patients, are screened for potential harmful side effects. Research methodology. I have chosen a quantitative positivist research methodology to conduct my research. The positivism research paradigm speculates that true knowledge is based on experience of senses and can be obtained by observation and experiment. The proposed research aims to identify any correlation between irrigation fluid pressure and the kidney function post-ureteral rhinoscopy. This requires observations of pressure and kidney function measurements. Thus, positivism will be the ideal paradigm to address the research question. Kurzweil J. in his book Research Design in 2014 defined quantitative research as an approach for testing objective theories by examining the relationship among variables. These variables in turn can be measured typically by instruments so that number data can be analyzed using statistical procedures. As the proposed study is intended to examine the possibility of the presence of a correlation between the two variables, number one being the irrigation fluid pressure, number two, the patient's postoperative estimated glomerular filtration rate, by measuring number data, which is quantitative data, comparing it, and eventually analyzing it with statistical procedures, hence quantitative research. The design chosen to conduct the research is quasi-experimental design, as it correlates statistics used to describe and measure the degree of association between two or more variables or sets of scores. It also lacks random assignment. The proposed study aims to measure the irrigation fluid pressure during the ureteral rhinoscopy procedures and then compare it to the kidney function post-operatively without offering a new variable or treatment. Added to that, the study population would not be divided into two groups to be compared and without any random assignment. Thus came the quasi-experimental design.